And now everything you say will be recorded and exposed, so be careful. Can be used against you in future in court. Anyway, thank you everyone for being here. We are starting another user group today, and I have the pleasure to introduce Stuart and Nick talking about blueprints for growth in the OutSystems Architecture Patterns. And they both go presenting, and after that we have like Kahoots with Margaret and some swags for sure for who is here and stay to the end for the Kahoot. Always that nice swags from OutSystems. And I'm gonna call Nicholas to start. Nick, welcome.
Well, thank you very much for that intro, Patty. Appreciate it. So let me click over. Yeah, I guess we can talk through to the agenda as well. So we've got a little meet and greet here right on time. For the topics, I guess, Patty, just to make sure of the time, we've got about, what, 20 minutes each?
Yeah, the full event is 1 hour. So my suggestion is you talk for 20 minutes, open for questions. Then Stuart talks 20 minutes, open for questions, and then the 10 less minutes for the Kahoots and closure. But if it's, of course, if you go 5 minutes here or people don't have questions and we go faster, you can work with the time.
I'm probably going to regret saying this because I usually talk for way too long, but I don't think I need the full 20. But that's fine. Just please give me a ping if it gets to about 25 past if I'm not paying attention to the time. But I'll be sure to try and stop myself from talking there. All right.
Margie just joined it during the event. I'm gonna leave, and Margaret is gonna take over. So be ready for that change.
I saw Hanu also get a thumbs up. So thanks, Hanu. I'm sure he'll keep me honest. Alrighty, so good evening, everyone. So my name is Nicholas van Wyngaard. So as you can tell by the surname and the accent, I am South African, now living in beautiful Sydney. So very happy to be here and very happy with the rugby result from the weekend, although 0 Australians care about rugby union, so it usually falls on deaf ears. I am a tech lead at Phoenix, so I've been delivering projects with Phoenix for the last 5 years now. I think I've gone over 5 years. So yeah, doing some tech leads within our projects with our customers, and also doing some consulting work the last year or so. So also doing some other non-development related, well, still software development related, but I'm not on the tools, some customer engagements, which has been fun. And yeah, that's why I was asked to talk a bit about composable architecture for scalability, just because we've recently had some engagements that tackled this exact topic, where we had a consulting gig for a customer that was struggling to grow their suite of applications in OutSystems with their current architecture. So we came in and had a look, and this is what we suggested, which was composable architecture. All right, so quick caveat before I jump in. I had way too much fun with generative AI creating some pictures for me. So it is a general theme within this presentation, and it got a bit ridiculous towards the end. Okay, so the most wordy slide. What is composable architecture? So if I can read the definition just so that we are all on the same page. So composable architecture is a system design approach that builds applications from independent, interchangeable, and reusable components. Each component is, and this is important, self-contained module, and our module, not to be confused with OutSystems terminology, module in a general sense, that performs a specific, well-defined function. So that's a very important concept of composability. Now, equally as important is what's the opposite of that. The opposite is, in contrast, would be a monolithic architecture where all parts of an application are tightly coupled within a single large code base. So very important concept. So obviously I got AI to generate me a picture just to show that, and this is what it came up with, which I thought was pretty good. So we have a very big immovable structure here to represent the monolithic application. which we have everything from the user interface, business logic twice for some reason, thank you AI, and then we have the database access layer and the database layer all in one single unit. And conversely, on the right-hand side, we have what is a representation of a monolithic, a composable architecture, where we have several microservices that each performing a very specific task and interacting with one another. So a very general concept within software development. I think we should all be probably are all aware of these concepts, which are good for us to refresh on what exactly composable architecture is versus a monolithic application. All right. Okay, so a very businessy, boring slide. Just a quick thing to point out that's quite important is, and I'm sure we've all experienced this in some way during our careers, and that's that teams do not operate in isolation. So the reason I put the slide up there is I just want to draw your attention to the application development block here, where if we think of this as a OutSystems digital factory, where we have some resource pool, which could be a combination of delivery partners or internal developers, external contractors, whatever that may be. We have some pool of developers that we can draw from, and we can spin up development teams to execute on various projects. This diagram here, what I'm trying to illustrate is that for many organizations, the reality is that they have multiple teams running in parallel, delivering at their own cadence, delivering their own products or features independent from one another. This is a common scenario. And yes, I did get AI to generate that same concept. So this is way cooler. You can see we have multiple teams working independently from one another and generating their own pieces of work or their own projects. So yeah, I think that's something we've all experienced, where we have multiple teams doing independent work from one another. Now, the question is, how do monolithic applications destroy productivity? So this picture, I'm trying to represent a death by merge. So we have the familiar OutSystems conflict resolution screen that pops up whenever we have the same developers working in the same module, and the conflicts coming up, and obviously having to select which code needs to be deployed to the server with your one-click publish. So I think I don't stand alone here in saying that it's not rare to have issues when doing these merges. Just the nature of OutSystems, where unit tests are done on the same server by all the developers, that we're all pushing code base at a rapid pace to the server. The merging conflict resolution can get quite complicated, and that can be a big productivity killer. At least that's what we find in our experience. Sorry, it keeps flicking over to Teams when I click. There we go. Another issue with monolithic applications is what I'm trying to represent here, and that is that you'll see here I have a fictitious my monolithic test application, and this application is trying to do it all. So you'll see it has various modules. This is a screenshot from Lifetime, just showcasing the various modules of this application, where we have the front end, we have the core services, the background logic, the database, as well as integration services, all bundled up into a single application. So why is this an issue? Sorry, one thing I do want to point out, if we just look at the names here, that'll be important later in the presentation. So we have the front end is the My RDX and reporting monolith app, which is just two fictitious applications, an RDX app, whatever acronym that might be, and a reporting app. So we have this front end that's trying to do, features. We have this front end that's trying to do these two separate things, RDX and reporting, and then we have another module here that has both security and role management baked into one module. So just take note of that, and we'll talk to that a little bit later. But the point I'm trying to get across here in terms of productivity destroyers is that because this monolithic application tries to do everything in itself, and that within OutSystems, the minimum deployable product that, or the minimal deployable component that we can push from one environment to the next is the application at the application level. That means that if we have parallel teams running and building in this same application, so let's say we have two teams, both of these teams are working within the monolithic test application. If one team is working on, say, the RDX component and the other team is working on the reporting component, they're both working in the same module in the same application. So that means if one team is ready to go to production before the other team, obviously we have to cater for that by either putting feature flags to block the new untested features from making it into the user's hands, or we have to slow down the production deployment for the team that finished first to wait for the subsequent team to come up, and so that their features can be tested and put into a state where they can go to production along with the already tested features from the initial team. So having a monolithic application, having a monolithic application while having several teams working on the same application is a productivity killer in terms of your DevOps pipeline. It tends to block up the whole system because one team's always waiting for the other. So I did get an AI picture generator on that, and it for some reason came up with the name, the Productivity Destroyer 3000, which is what apparently Gemini likes to refer to monolithic architecture to. So yeah, I thought it was quite a cool little comic representation of what monolithic architecture can do to your development cadence. All right, so let's get practical in OutSystems itself. So what do monolithic applications look like in OutSystems? So I'm talking particularly about O11 here. I'm not talking about ODC. Sorry, it keeps going back to Teams. Here is a very plain example. So I showed this in my previous screenshot in Lifetime, but here we have a test monolithic application where we have a front-end module that's trying to do two things. So it's got the RDX and the reporting feature that's baked into it, and then we have a core services module that's also trying to do two things. So namely the security as well as the roles. So I've got a screenshot here of what that may look like. So within the front-end app, we could have this RDX UI flow here that has the various screens specific to the RDX functionalities. And then we have the reporting screens, or the reporting flow with the screen specific to the reporting functionality. So we have this front-end application where we have these two UI flows, and let's presume that these two UI flows operate completely independently from one another. And they can operate they can operate within individual applications if need be, and there's no reason for them to be in this monolithic structure. And similarly for our security and role module, we'll see here that we have actions related specifically to roles as well as to security, and we have our roles defined over here. And again, let's assume that these actions can run independently from one another, and there's nothing really tying them together. So here we can see, looking at this monolithic application, if we've identified that, okay, well, there's clearly two different services that we're trying to do within this specific front-end application, and clearly there's two different services that we're trying to do in this back-end module. We then ask the question, okay, well, what would composable architecture look like in O11, say, for that exact scenario? So jumping over to what composability might look like, we could think we could try another tactic by taking out the RDX services screens, because we've identified them as being an isolated feature that could form part of their own application, and we could bundle them into their own specific application, or module, to use a more general sense in terms of the definition that we read earlier. In OutSystems, if we think, okay, let's put the RDX services in its own minimum deployment package. So we know now that, okay, we have the RDX services in its own application that we can deploy independently from anything else in its own lifecycle. And similarly, we can do the same thing for the reports. So we can take the report screens and we can bundle that into its own application. And so now we know, all right, so we have these reporting screens that are independent from the RDX screens. We've identified them as being their own business feature application, and we've created our own independent application that we can deploy independently from anything else. And we can do the same thing for, just to jump across here, for roles and security. So the natural question then is, all right, now we have these two applications, but previously they were in a single application, and the users would be experiencing them as a single application with different screens. So i.e., the RDX as well as the reports were in a single application, so the navigation seemed natural, and there were menu links to each one of those screens or each one of those functions, and perhaps a portal page where you can navigate to those different functionalities. So then what we do is we introduce a third application, which is a portal application. And this portal application essentially just links using URLs, links those two applications into a unified experience. So this is almost resurrecting that the composing layer that used to be in the 4-layer canvas within OutSystems, but obviously we don't use that terminology anymore. But it's the same principle. Now, obviously, this doesn't work for every factory. So some factories have very specific requirements around the applications needing to be in the same module, or there's no need to have them linked together in some kind of portal. But let's say in our scenario, we assume that all we want to do is we want to match that unified experience where the user clicks through using URLs in a portal application to these two different features that were previously screens in one monolith. Now all we're doing is navigating to separate applications outside of the portal, and we can build functionality within the applications themselves to navigate back to the portal. And we can also use shared themes and shared menus in order to help us to navigate between the portal and the applications. All right, so how does this help us? What have we achieved in doing this? So one of the major achievements that composable architecture, one of the major benefits that composable architecture achieves is shown in this screenshot over here. So here I have a deployment plan in lifetime. So you'll see here, I have my app for my RDX services, I have my app for my reports, and I got my roles and my security applications. I remember these are applications, not modules. And then I've got my composable architecture application here at the top. Now, in this deployment plan here, I have them all in the same deployment plan. However, if I have architected my service applications, which is the roles and securities correctly using, say, service actions, and I've ensured that they're loosely coupled, then I could, in theory, only deploy the reports application individually, and I could take all the other applications out of my deployment plan. And similarly with the RDX services, I could do the same. Or if I just want to update my portal, I can do the same and just deploy that single application upwards. So that gives us the ability to have teams running independently from one another and in parallel, and they could deploy at their own pace. So you can now envision a setup where we have, say, an RDX project team that their responsibility to look after the RDX product, and a reporting project or a reporting team that where their responsibility to look after the reporting product. So they can run at their own cadences, have their own milestones, and have their own deployments to production. So that's one of the major achievements, or one of the major benefits of going with composable architecture. And we can see how that can be beneficial to big factories running with teams in parallel. All right, so I think this is saying a lot of what I already said. So individual application deployment. So sorry, this is just asking the question, how does composable architecture increase productivity? So again, individual application deployment, as I just mentioned, and then also it separates developers working in different modules and applications rather than working in single modules and applications, and then avoiding that the conflict resolution, so death by merge, as we previously mentioned. All right. Okay, so you might have a question. Well, what if I need to access those applications from 2 different portal apps? And let's say, for example, each one of those portal apps have a different look and feel, or a different security, levels that we need to apply to them. So one method that we can tackle that is, if we have a look, we could change, this is the reports application, we could just put input parameters into the screens themselves. So in the URL, the portal that's calling the application, it can tell the application, hey, I am portal application ID 1, so please adjust yourself accordingly to look and feel the way that I look and feel. And alternatively, portal application 2 can do the same. So this was an example actually that we had in our previous engagement, that we had 2 separate portals, an internal facing portal and an external facing portal, and they had subtle differences in look and feel, but significant differences in terms of the menu options that we needed to show. So we actually created a dynamic menu that was in the shared theme, and that dynamic menu was generated based on which application was actually, which portal was actually calling that application. So what that allowed us to do is to have a single reports application that was being called from several portals. So we only had to build it once, but then we could also have a granular, control of what we wanted to show the users, or whatever else we wanted to change in the screen based on the context that application is being called from. All right. I think this is my last slide. I just want to have a quick word on blocks. So you could ask the question, but why don't we use web blocks? That's a natural question to ask, because web blocks does seem to solve some of that problem, where we can have a web block that has the defined, say, reporting UI, and we can also bake in the business logic, and then also maybe use that portal application ID to change things as we need to. However, as soon as we use web blocks, we go down a tightly coupled route. So that means that all the portal applications will then be tightly coupled to that web block. So if we have teams running in parallel, again, say teams for different portals, they're all beholden to this web block. And as this web block changes, they will have to be deployed along with that web block, because it needs to inherit that look and feel. But as soon as you have an application-based modularity introduced for composability, then you decouple the applications completely, and you can have that independent stream of development. All right, so I told Gemini to generate the coolest, most dramatic thank you slide for the end of my presentation about composable architecture in OutSystems, and this is what it came up with. I would say that's a bit disappointing, but we're getting there. AI is almost there. So thank you very much, everyone, for your attention, and I will now kick it over to Stuart.
Thanks, Nicholas. That was awesome. And look, I think that's a pretty decent looking image. It's spelt thank you right, which
Yeah,
it's not that common for AI to get that sort of detail right.
True.
All right, share my screen. Okay, now I'm going to share an entire screen. Right. Here we go, slideshow. Okay, so yell out if you can see architecture patterns for ODC and some tartan. No? Yes?
I can see your screen, yeah.
Yep.
Excellent. All right. Well, so now that Nicholas has talked about composable architecture for OutSystems 11, we're going to have a little bit of a talk about architecture patterns for ODC. When I first came along to do some work on ODC, it was a little bit of a shock to the system. Look, it's not that bad, but the applications are, the React web apps are still actually the same, but the architecture of the platform's a little bit different, and the way you actually compose applications is a little bit different. But I think the things that Nicholas has said still apply to ODC. So who am I? I'm a grumpy old developer. I've been developing for, I think, thousands of years. Actually, I'm only 21, but I've had a really hard life. I've worked at a consultancy for a number of years, and now I'm building a practice in a fintech. got a lovely family who I bore to death with dad jokes. So what are we going to talk about? Get to the point, Stu. ODC and OutSystems 11 are different. There is architecture pattern training, which is awesome. So I'm not going to go through all of that training, but I'm going to just share some real world patterns that, and the reason for that is with the architecture sort of patterns they talk about, look, my experience is you might use one or two of them in the whole course of your, OutSystems life. Some of the other ones, they're good ideas. They're applicable for when you need them, but you don't need them, It's only when you get to that project, oh, I need that architecture, right? So I've actually kind of taken some smaller examples of, you might actually call it design. Let's face it, architecture is just big design, isn't it? Some things that I think you'll use on every application. And if you don't, well, I was wrong. Okay, so let's get into it. Okay, so OutSystems Develop Cloud and OutSystems 11 are different. Surprise. Well, so how are they different? Well, OutSystems 11, it's cloud ready. So it runs in the clouds, hosted for you. You don't have to worry about it. But you kind of do a little bit because let's say you're running, version, I don't know, 211 of the platform, and 214 has come out, and it's got some security fixes. You actually need to upgrade each environment for the platform. Test your application still work, and just run a redeploy in place of your applications in the environment. So that means that you're not going to do that every sprint. You might do that once every year or every 2 years even. It takes longer to get platform updates. You can get them whenever you want them though. So, it's up to you, but you've got to schedule it yourself. ODC, cloud native. So it's actually a little bit closer to the cloud application. So for example, in OutSystems, well, no, I'll get to that. But so for ODC, if you want to do a platform update, you don't really have to do anything. Platform updates are happening all the time behind the scenes. So you're never going to be 2 years behind or a year behind in terms of security updates. Security issue happens, gets fixed, gets deployed into everyone's ODC environment. In OutSystems 11, applications and modules run separately. Each module is its own web application, even if it doesn't have a UI. Now it runs its own application. Sometimes you don't even use that application. You're just calling service actions that get compiled in. I'm going into too much detail, I know, yes. But in ODC, applications are they're the only web applications. So all of those sort of modules that Nicholas was showing you inside an application, they get compiled into a container, Docker container, and then deployed into a Kubernetes cluster. What's that? Well, that's what it runs on. And that introduces some architectural issues for us, and that's really essentially the nature of the architectural differences, because you can have data storage in modules, you can have all sorts of things in modules like you can in a full application. Really, in OutSystems 11, in ODC you can't have data storage in libraries. There's no modules. You can build libraries. If you want to have data storage in a shared component, you actually deploy a separate application, use service actions, that's fine. But an application and libraries, not application and separate modules. Extensions. This is one that really got me, and it took me a while to get my head around. Extensions in OutSystems 11, it's really just some .NET code that you're running alongside the other code in your application. So you can do things like .NET reflection. You can have a look at the different types in the structure, and you can write some generic code that will pull out the values and do human readable change logging, for example. In ODC, the external logic runs out of process. When you're calling something to, let's say, generate an Excel document or do something with a binary document, or just call some other .NET code that you want to use in your application, it makes a HTTP request, calls a Lambda function, and then returns the result to your application. So that is the right architecture for us to be using now. Running things in process is how are you honestly going to control the security of that in an application? You know, let's just not mention any of that in terms of OutSystems 11. But for ODC, it's running in a separate Lambda. It can't mess with the runtime of your application. It can just return a result. But what that means is, if you think about it, you've got a .NET object in your OutSystems application. You can't send that through a HTTP request. You know, you can convert it to JSON, but that means you're just really sending a JSON string over. So that's fine. You can do that. But you can't send the object and then evaluate the object, have a look at what attributes it's got, and do some generic work on it. Also, if you want to send a binary document or do any work on a binary document, you have to send the whole binary document across that HTTP request. And surprise, the size of those requests, there's a maximum size of 5.5 meg. So we can get around that limitation. We'll talk about that later. Identity providers. So in OutSystems 11, you can hook up an additional identity provider for your application, like Microsoft Entra ID or Okta or something like that, some sort of Active Directory. That's what they used to call it, isn't it? In ODC, you can you can also do Facebook and Google sort of authentication as well in OutSystems 11. With ODC, you can add multiple identity providers. It's a lot easier. It's kind of built for it. There are some limitations with the identity provider, but that's because it's implemented in a way that you can't attack it. Like in OutSystems 11, you're really free to do a lot with identity. So it's a little bit more locked down in ODC, but it opens up a brighter future for us because it's standards based. It integrates with a lot more, and it's going to take us forward into the future to where we want to be. OutSystems 11, you deploy multiple applications at the same time. In ODC, you don't. You just deploy an application individually on its own. Maybe that's something that's going to come in future where you can say, hey, I want to deploy these 3 applications, go. In OutSystems 11, deployments can be really quick in OutSystems 11, but typically, if it's a reasonable sized application doing something real, it's going to take, something like 30 minutes to do a deploy because it recompiles everything. It's a great process, but it does take a little while. ODC, because all you're doing is you're taking that Docker container, it only gets built in development. To deploy to other environments, it just gets copied into that environment, and then the Kubernetes cluster says go. Well, it's a bit more than that. I don't really know what's going on underneath, but that's why deployments take less than 1 minute. It's amazing. Love it. In OutSystems 11, you've got Lifetime and Service Center. You've got all your management tools. In ODC, it's all together in the one portal. And again, that portal is being updated. When a new feature gets added, it just appears there. It's not like you have to update the platform like you have to do with OutSystems 11. So the other big thing that ODC has is you can generate apps with, I'm sure you might have heard something about that at some time in the past. If you haven't, what rock have you been hiding under? There's plenty more differences, but they're the major ones that I really wanted to call out. So back to applications and libraries. So applications run in a container. The libraries get compiled into the container. So what this means is you generally have larger applications because you're not splitting your data storage amongst a bunch of different modules, you're actually putting your data storage in the application. And look, this might be a bit controversial, but you'll be using your libraries like you should have been using them in the first place, which is you're not depending on your application code. You're building libraries that are more generic. Like Nicholas's example of using a block, you know, if you used a block and you put all your reporting code in that and then hit the database from that, you know, that really should be an application, not really in a library. So, you know, what Nicholas's team did looks like the right solution. But if you think about OutSystems UI, had a mental blank for a second there. If you think about OutSystems UI, all of its blocks are generic. You can use them anywhere, really, as long as you're using them properly. So you should really think about your libraries like that. You can make them more specific to your business domain. In fact, that's generally what you'll do. But try to have the logic and the workings of the application in your application, and then, you know, structure things and have separate generic things you can pull in from your libraries. I'm not explaining that very well. Here's something very interesting. If you have a library, let's say you have a common library that you use for your organization. It's got all these common functions like getting the extension of a file name or formatting, you know, a person's name in a particular way your company likes to do it, or a phone number or whatever. And then you use that in application number 1. And then you make a few changes to that because, you know, you realize you messed up the logic in the phone formatting. But that application you don't want to deploy at the moment. You're working on application 2, but you want to deploy application 2. What will happen is that library will get compiled into application 2. You deploy that up to test and then into production. In production, you've got application 1 that's using version 1 of your common library, application 2 that's using version 2 of your library, and that's totally fine. It's not like, you know, you have to, if you upgrade OutSystems UI, bang, you have to do all of your applications. So I've been waiting for that for a long time. And lightning fast deployment, mentioned that, so let's move on. All right, so I think I talked about all of this, so I really should have read my slides before I went through the other slide. So limitation on size of requests. So that human readable change history doesn't work because you can't actually use .NET reflection to look at objects. Even if, like, I've tried to use the JSON diff thing to get like JSON for an entity and then send that into external logic. And then I get into the external logic. It's like, what do I do here? There's nothing to do. So that's a problem. But it's also, it's good. You can convince your architects that your application's more secure. If they didn't realize it before, well, you know, now you don't have to worry about it. Okay. So in terms of architecture patterns for ODC, there's some awesome training. So let's just jump over here. Here it is. Architecture patterns in ODC. Now, I'm not going to go through all of those because it's just go and have a look at the training. You don't need to listen to my high-pitched, whiny voice to learn anything. And it's got a lot more really good architecture patterns in there. So do yourself a favor, go and do that. If you haven't, I'm sure you've already done it anyway, but if you haven't, go and do it. It's good. Back to the slideshow. All right, so now Nicholas talked about a shared theme. So this is the simplest one, so, you know, start you off easy. This is the same in OutSystems 11 as in ODC. You've got 2 different applications, but you have one common brand for your organization. So the difference in ODC is that theme is a library. So you create the theme in the library, you share it amongst your applications, all good. And if you update that theme and you deploy directory, you don't need to redeploy vacations. That's still using the older version. You know, it's your UX team is just going to say, can you update the theme in your vacations app? But the OutSystems infrastructure won't. It'll just keep running. So it's better to argue with people than with technology, because with people you can win. In theme inheritance, again, same as OutSystems 11. This is more realistic, right? Because your company will have a theme, but then you'll have two different applications. They'll have their own needs and possibly their own UX or UI designer. So there will need to be some differences. This example is web and mobile. You know, there'll be differences in the theme there, but they're using the base styling for your company. What I'd also point out is, and what I normally do is, in an application, I will have the application have its own theme as well. What you can do is just take the application and point it directly to your web theme or your mobile theme. But I tend to find that within the application, again, it has its own needs over and above, you know, the common web theme that you might have. So you need a place to actually put that without polluting your themes that are shared across applications. What we also find is gradually, as you perfect those UI techniques in that application, someone's going to go, oh, I like that. Can I use that in my application? That's the time when you'll actually move that down into the shared application. Right. So that seems no big surprise there. It's just libraries in ODC, that's all. All right. So external logic with documents. Now, this is the more challenging one. Now, a really good example of this is the advanced Excel library. So Hanno's on the call. I think Hanno was on the call at least. He's holds that component's hand on many occasions. So in ODC, let's say, let's have a look at the how we do that in OutSystems 11. So we've got our application. We call the Excel library, and in OutSystems 11, it's called Advanced Excel. We create the workbook, and we get a reference passed back to the workbook. And we can do that because the code's running in process. And then we go through all of our data, and we write a cell. We call to the library, pass the reference to the workbook. You know, we format it. Then we go auto fit because, you know, your clients never like it when all your columns are jammed up next to each other. If you're not using an auto fit, now's the time. Tomorrow, I want you to go back to your Excel generation code and put auto fit in. Generate a binary, and then save the Excel file or email it or whatever you do with it. So easy, right? Now we come to ODC. So we'll call the Excel library, create a workbook. Now remember, that's a HTTP call, so we can't return a reference. So we get a binary workbook back. And then, now notice before, in this really poor diagram, this is meaning we're iterating through there and calling write cell many times. In ODC, we don't do it like that. We go through our data and we append to a list of cells all of our formatting, all of our data, and then we make one call to the library. So that's the big difference. When you're working with binary documents and you're manipulating them, don't write data individually. It'll time out. Even though it's only take a little bit longer, if you're writing 20,000 pieces of data, your request is going to time out. And even if it doesn't time out, your users are not going to be happy, especially if they're grumpy like I am. So you write cells all in one go. It's really quick. Returns your binary again. Then you call auto fit again, because you must call auto fit. I'm not letting you get away without doing that. I should have put that in the code questions. And then you return a binary again. So we're passing a binary around a number of times here. That's probably the minimum amount you could get away with. but it works fine as long as you write all the data in one, maybe a couple of calls instead of thousands of them. And the request size is 5.5 meg. Right. So, working with documents, we want to avoid passing the document back and forth as much as possible. I mean, we were doing that there, but we minimize it. So we use bulk actions like write cells. Consider the size limitations. Now, this is the secret sauce. This is in the OutSystems documentation as well. That when you have a large document that may be bigger than 5.5 meg, you store it and then you pass an ID of some sort or a URL to your external logic, and that'll call a REST API to retrieve the document. So that's the way you can get away with larger documents. Let's have a look at how that would work. So we have an application, I don't know, someone's uploaded a document, or we're going to virus scan a document. So we send it to our document API, we store it, gives us an ID. We call our external logic document service, and we give it the document ID and a URL to call back. That URL is for our document API. And I guess you could have said, Stu, why didn't you just put the document ID on the URL? Well, you know, thanks for the code review. You're right. I probably should have done that. Anyway, never mind. So we call the REST API to get the document, and then we do the virus scan, send back the result. Maybe we want to delete the document when we're done. I don't know. So it's, don't think that it's a limitation, that the 5.5 request limit is a limitation on what you can do. You just have to use a different pattern. Right, auditing. This is a good one. This has stumped us for a bit. So look, here's your standard auditing kind of framework. You've got an audit, it's got a description, you know, username, IP address, what entity is the ID. An audit event, was it a create, a delete, or maybe a business event like sending a notification, or I don't know. And then you've got audit attributes for the attribute name, the new value, the old value, you know. And then what type of change is it? Is it new? Is it a delete? Is it a change or an update? So that's our change log sort of data storage. How do we get stuff in there? In OutSystems 11, this is what we used to do. We used to go compare objects, uses .NET reflection, goes through all the attributes of the object, reads the values, compare them, look up labels for foreign keys. So instead of saying ID 1, it can say ID, you know, policeman, fireman, ambulance officer, or whatever. So you don't need to guess what the type of thing it is just by what the value of the ID is. And then it sends back your changed attributes and you can store them. Easy. But that has to run in process to use .NET Reflection. I probably said that a million times, right? So in ODC, we're going to get this audit record, which I probably should have showed earlier. So the secret here is, can we pass objects? No, we can't. Can we use .NET Reflection? No, we can't. Don't panic. That's step number 1. Step number 2, keep it simple. You're going to be shocked at how ridiculously simple this is. So we're just going to have an action that will, we're going to manually grab the attributes of the entity. Let's face it, how many times do you have to do that for an entity? Once. You write this once. So what this is doing, by the way, is passing in a new and an old entity, and it's returning a list of attributes with a name, a new, and the old value. So instead of calling this thing that'll automatically do it for it, you have to write this action for each entity that you audit. And I've found it's no slower, well, it's probably a little bit slower. It's not much slower than doing it the other way. So this is what those little list appends look like. got a little helper function there that will create this structure for me, because that would have been a pain. So for this one, make created, I don't need to pass in the previous one because it's a create. So there's no object in the second object. So what we do here is we go is new is has the previous object got no ID, so there's no entity. So all we do is pass in the new values. We format them, and the formatting them was always a problem with the human readable changelog. You can format them any way you like here. If it's updated, then we use the make updated function and we pass in the new and the old version. It'll create that structure for us and put in the new and the old version. So this one's only got 3 attributes. You know, a real entity is going to have 10 or 20 attributes. So this will be 10 or 20 long. You can separate it into 2 list append alls if you need to. I'd probably do that. Right, so keep it simple. We query the entity to get the related objects, but so what am I talking about there? So this one doesn't have any static entities or other objects that might have labels that we need. But let's say we did, for this get changes call, we'd actually want to create a structure for that entity that has all of the entity attributes plus the labels that it needs. So then they're available for these calls where you want to go make created, you know, job type, policeman, ambulance person, or whatever, and then job ID, whatever the ID was. So we query the entity with any related foreign objects if we need them. You might want to consider adding extra attributes for context. Maybe you've got some sort of request and then you're adding a note for that request. Maybe you want the summary of that request when you're doing the change auditing of the note. I don't know, just an idea. We need to create a copy of that sort of action per entity type. We identify the attributes and add them in a list append all. We turn them in a list. Once we've got that list though, that's just common. So we can just process that in one sort of common way. All right, and that's it. You'll notice all the Scottish references in there. So Murantang means thank you in Scottish Gaelic, apparently. I should know, but I don't really. I just looked it up. Thanks, everyone.
Thank you, Stu.
Thank you. Now stop presenting.
All right. Thanks, Nick. Were there any questions before we start with code? I know we're going to go a little bit over, but should be worth it.
That's my fault. Sorry. Nick was great. He finished right on time.
Yours is vastly more interesting, though.
It's just because I'm better looking. That's and funnier looking. I think that's what my mates would say. I'll shut up now.
All right. Doesn't seem like we have any questions, so let's start the Kahoot. I'm just going to make sure that I'm going to show the correct screen. Of course, I wasn't too ready, but I should be right about now. Okay. All right. So, music. And yep, please join this link. I will copy it to the chat and input the game pin 758891 if you'd like to join. Kahoots, we have swag prizes for the top 3 winners. And that arrives to you in a couple of weeks or so, but they're definitely worth it. Just as worth it as you being here. So let's see. Got a few already.
Thanks everyone for sticking around and listening to me go a little bit longer too.
Really appreciate you, Stu. And
Oh, you're the best, Margaret.
yeah, no, it's you have been very generous with your time with all these user groups. So sharing all the topics and ideas. And if there's anyone here in the call also who'd like to hear any specific topics, yeah, please share it on the chat while we're waiting for others to join. It's always good to hear from the audience, right?
Well,
Yeah, I'm actually
go ahead.
we're doing my first ODC development tomorrow, actually. So it was actually quite timely. It was interesting.
Ooh,
Awesome.
Done the cert and everything, but haven't put rubber to road yet. So pen to paper, I guess. So we'll see. That'll be quite interesting.
awesome stuff. All right, maybe 10 more seconds. How many do we have?
Oh, Nick, the rule is you're allowed to join the Kahoot as long as you lose.
That's okay. I generally do pretty poor in Kahoot, so
So
All right. A Kahoot by Kahoot, okay? Right, so fastest answers, correct answers get the highest points. So what's the core idea behind the composable architecture in OutSystems? Nick has provided the longest options ever.
my absolute pleasure.
And there's a character limit in Kahoot, so I'm kind of like, this still making sense. All right, 6 people got the correct answer. Create reusable independent modules to build applications or business features. We've got Seb at the top. We've got Abhishek, Satish, and Joao, and TDR. Go to the next question. True or false? A monolithic app is a single tightly coupled unit, while a microservices app breaks down a system into small independent services. We've got 6 answers. And the correct answer is true. Cool, we still have Seb on the lead. And Din is now on top 5. Next question. Which of the following is a key benefit of adopting a composable architecture in OutSystems? And this may or may not be AI generated image. I'm not sure. Again, long answers. All good. Thanks, Nick. All right, correct answer. Sorry.
So I need to eliminate all bugs and technical debt.
Improve scalability, maintainability, and reusability of app components.
wouldn't have anything to do if we did that.
Let's go to the next question. Question number 4. In a composable OutSystems architecture, what is the role of an end user module? Right, correct answer is a top layer consuming services and data from underlying core and library modules. Let's see who's leading. Abhishek Bhabhi is leading, followed by Seb. Joao is on 3rd place. Now we've got Sekar and Tin on 5th place. Right. Next question. ODC is different from O11 because their logos are different. ODC is a type of porridge. ODC is cloud native. That's the correct answer. All right. Abhishek has a streak with 5 correct answers in a row. Well done. 6th question. Architectural pattern training includes library usability, library reusability, library inability, but in practice. And let's see, we've got Satish on 5th place. Next up. How should I build a document with ODC external logic? Return a reference to the document object, pass the binary data back and forth, use bulk actions, or blow it out of my bagpipes. You clearly see a theme here. Use bulk actions. Ah, only 2 got the correct answer. Ooh, tricky, tricky. That makes Joao on the lead, followed by Abhishek, and TDR is making a comeback. Well done. 8th question. How can we pass a large document to an ODC external logic action? As a parameter with a callback to a REST API as a zip file, or whatever is in the picture. With a callback to a REST API. I like that someone answers one of the green ones. Last question. How should we build change logging in ODC? Don't panic. Separate action per entity, process the list of attributes, or all of the above. Don't panic. It's the last question. All of the above is the correct answer. That was another tricky one, too. All right, let's see who are the top 3. Congratulations, Joao. On 3rd place, TDR, and Abhishek. Well done, well done. So
Well done.
I'll type my email address here, and please send me an email so I can arrange the swag kit to be sent to you. Is that correct? Yep, that's right. Oh, good. Thanks everyone again for staying, and thanks again Stu and Nick.
Thanks, Nick. Thanks, Margaret. Thanks, everyone.
Thanks to you. Thanks, Marge. Thank you, everyone.
Have a good day, good night. Thanks all.
Thank you.
Thanks. Bye.
Good night.